Light velocity synthesis for moving observers. Light theory that Hamma is not flying. July 8, 2020, 22:22. Now, let's look back at the Michelson Morley experiment and do velocity synthesis when the observer moves. First, the relationship between special relativity and Michelson Morley's experiment, experiment. First of all, it must be pointed out that the principle of light velocity invariance, as often misunderstood, light travels at the same speed from the perspective of a moving observer. It is not a thing. As clearly stated in the paper, the principle says that the speed of light is irrelevant to the motion of the light source, and does not mention the motion state of the observer at all. This point is extremely important in understanding the composition of Einstein's logic. Since the problem is the motion of the observer equals orbital motion, if the effect is not explained, the principle of light velocity invariance unrelated to the motion of the observer can be said from Maxwell's equation plus absolute stationary coordinate system. The speed of light is constant as the same inertial system, local, as the observer. Initially, this was interpreted as Maxwell's equation holds only in the absolute static coordinate system 1, and in inertial systems other than the absolute static coordinate system, it was interpreted that the Galilean transformed Maxwell's equation holds. However, even if an experiment with sufficient accuracy to find an absolute stationary coordinate system, Michelson-Morley experiment, etc., was performed, the effect of the Galilean transformation due to the difference in the inertial system was not observed. After all, neither the free space of electromagnetism, the Newtonian dynamics, nor the Galilean transformation is bound to the absolute stationary coordinate system. In Newtonian mechanics, since there is no absolute stationary coordinate system in the universe, all velocities are always relative velocities seen by the observer at that time. According to the theory of relativity, the relative speed of light in a vacuum is always constant regardless of the speed of the observer. In fact, it is undeniable that the changing speed of light is bound by the speed of light. This seems to have been limited to Lagrangian. The equation of motion was described as a second-order system of ordinary differential equations, Euler-Lagrange equation, using generalized coordinates and generalized velocities in the Lagrangian form. On the other hand, in the Hamiltonian form, the motion was described by a first-order ordinary differential equation system, Hamilton's canonical equation, using generalized coordinates and generalized momentum. However, the most characteristic feature of the Hamiltonian form is that the equation is symmetric and that the generalized coordinates and the generalized momentum are treated independently. This fact means that the Hamiltonian system is more convenient for examining the symmetry and integrability of the system. Because the Lagrangian form only deals with the symmetry on the configuration space, the Hamilton form also deals with the symmetry on the phase space, equals cotangent bundle of the configuration space. That is, the Hamiltonian form allows more transformations. If you have something that hasn't revolved around the globe, bring it. It is a story. Velocity synthesis when observer moves. The following is the velocity composition as seen from, which is moving away from the observer and at the speeds of from, to, a, to, d, are patterns in which the relative velocity does not exceed the speed of light, e, and f, are exceeded, and g, is the retreat velocity of the expanding universe. It is a light speed pattern. From the perspective of the observer, the fact that the speed of light in a vacuum is constant means that the speed of light is the observer's time, so if the observer is moving in the spatial direction, the speed of light is brought to the time axis and the waves move in orthogonal directions. You have to decide the speed. Naturally, its wave velocity becomes superluminal velocity. In the theory of relativity, this wave velocity is constant and the light velocity is invariant, and is converted accordingly. However, when the speed of light changes due to the movement of the observer, it becomes superluminal and does not match the actual speed of light. Although the first and the first dimension are delayed, the coordinate transformation that can only Lorentz contract in the traveling direction in 3 dimensions is far from reality. On the other hand, gravity does not work because it does not become invariant to the Lorentz transformation even when trying to make a 4-dimensional vector within the range of special relativity 32. General relativity is needed to handle gravity. It's okay if you don't have any problems, but even if you accumulate unsolved problems and make ad hoc hypotheses to match them, you will only get stuck and physical separation will accelerate. Optical frequency shift due to 3 kinds of acceleration. Hi, am is non-flying. Also light theory. I was confused myself when I explained some unsolved physics problems, so I'll put them together in an easy to understand manner. Earth flyby anomablog.goo.ne.jp. Next, we will do the equivalence principle when the speed of light changes using the perihelion movement error of Mercury.